Hi and welcome to TechteamGB. This video is all about the massive update that I've been working on for my open source response time tool, specifically the desktop software, hence the monitor that's here, as I want to take you through some of the major changes that I have, implemented over the last couple weeks and months, and literally 1,000+ hours of me sweating over some code. So hopefully you like it. Now, if you don't know, let me give you a quick rundown on what this all is so that you're not just completely lost as I go through it. The Open Source Response Time Tool, or OSRTT, is a tool that I developed to effectively test monitor response times, and technically total system input lag as well. We'll come onto that later, but essentially it is a light sensor and a microcontroller, along with the required components to make that work and be reliable. As for the desktop app, there have been some pretty major changes here, so let me walk you through. Now, since this popped up, I thought it'd be a good thing to note. When you're testing displays, the panel itself, much like a car's engine, takes time to warm up physically, and when it's cold, when it's not been running for normally at least 30 minutes, the panel is often slower to respond and often inconsistent to respond as well. So it's highly recommended that whenever you're doing display testing, especially for things like input lag and response times, that you let the display warm up first. You have it on and running so that it can heat up and function normally. And I have a little warning for that. So just in case you haven't had that up and running for a while, that pops up for you. Otherwise, the app itself has, like I said, had a bit of a redesign. So the device connected is now a lot clearer. The actual buttons that you use to start the tests are a bit clearer as well. And there have also been a few major changes to how you go about using the different settings. Now, I'll come on to the settings in a second, but first I just want to mention a couple of essentially back-end things that you likely won't notice, but I feel I should mention, especially if you do have one of these tools. The first thing is that instead of having the data be processed, as in the raw samples be turned into response time numbers, instead of that happening at the end of each cycle, every time that it's finished doing one cycle, it goes and, or it used to go process all that data, and then it will start the next cycle, and then once it's done all of that, it will then average and do outlier rejection on that data. Instead of doing it as it cycles, I now collect all of the data and then process it all as one lump. That means that it's technically less likely to crash during a run. There's still a couple of checks that I do for every sample that comes in, and you can suppress those with one of the settings so that it won't just crash the test, it will continue going and then tell you that there's, it won't run, it won't work, whatever else. But doing it this way means that you will always have all of the data saved, even if it can end up processing that data later. One of the other issues that I had from the previous versions is enabling and disabling VSync and setting the frame rate limit. As you can see, the settings for VSync and frame rate limit. So just to make it clear, the frame rate limit is what in-game in Unreal Engine 4 FPS the test will be limited to. The reason you might want to set that to below your monitor's refresh rate is to test its variable refresh rate support. Setting your monitor just to fixed 60 Hz, for example, isn't the same as having it still set to 165 Hz like this Gigabyte M32Q, but then having the game actually running at 60 FPS. Those two aren't the same, and so that's where that frame rate limit is there to be able to test. VSync is very useful for getting generally the most accurate results. as in you effectively give more of a lead time, more input lag essentially, or latency, because VSync is buffering those frames. I think it's either double or triple buffering the frames, which means at say 60 Hertz, you're going to be waiting 16.67 milliseconds or whatever times 2 or 3 before you see any input, any change happen, which does mean that your files are likely going to be larger when you're running the test, and it also affects the input latency results, as obviously VSync is affecting that. So generally speaking, VSync is currently set by default to off or disabled, but if you want the most accurate results and you don't mind it taking a little bit longer and taking up a little bit more storage space, then setting it to enabled and increasing the capture time is what I would recommend there. And the main thing, the main issue that I had with the previous versions isn't that those settings weren't there. They were. They just didn't work most of the time, which is a quirk of both the code that I'm running and a bit of Unreal Engine. So I've now set it up so that the both frame rate limit and the VSync setting is set by the desktop app instead of effectively the device pressing hotkeys to toggle that state. And so that means that it's much more reliable. It will work every time rather than inconsistently or not at all, which I'm happy to say is now fixed. All right, let's take a look at this new settings window. I'm really excited about this. It's much better than the original sort of toolstrip menu settings, where whenever you click on one of them, they disappear. It's kind of frustrating if you want to change more than one setting at a time. So you can now access the new settings menu from either the setting in the toolstrip or the big golden test settings button in the middle. So if you open that, you will find the new test and results settings. Now, in future, a future update will make this a tabbed window where you can scroll through all of the different settings that the program will eventually have. But for the time being, this is all of your actual testing settings for the response time test in particular. At the top, you have the sort of toggle between recommended and advanced. Recommended is all of the same settings as before. In fact, there aren't many new settings here, and for the actual response time and overshoot settings, those are all the same. They're just displayed a little bit differently. All of the recommended settings are the same. If you want to learn more about these, you can check out the video all about the different methodologies that I have that I already mentioned in the cards above. But if you want to leave it as is, that's perfectly fine. But if you want to change any of those settings, just change it from recommended to advanced, and then you can toggle any of the settings that you want. It's also set up to be a sort of adaptive setting. So for example, if you change the tolerance style from the gamma corrected RGB values to light level, then you obviously don't have a fixed RGB light level. That doesn't compute. So you can select between 3% or 10% as a tolerance, with 10% light level being the sort of original old school VESA standard. If you then set it back to RGB values or gamma corrected, it then swaps over to being 3% of the RGB value, which is what Tim from Hardware Unboxed uses, or 10% of RGB, or a fixed RGB5 or RGB10 tolerance, with RGB10 being what Simon from TFT Central uses instead. The same goes for the overshoot settings. Again, you have either effectively gamma corrected or not, so based on either the light level or RGB values. And when you use RGB values, you have the extra option to display the raw RGB values as is, rather than, when you select raw light level, there's not going to be a raw light level to display. That just won't make sense. And so that is what's set up there. I should also mention that the option to save to the original Excel heat maps is still in the program, but I personally wouldn't recommend it. Now, all of the results still get saved to the folder in CSV or comma separated value files, So if you do want to copy and paste that data into the Excel heat map, especially if you've customized it to how you'd like to display the data, then that's perfectly fine. But the program now handles the heat maps itself in a much better and I think much more presentable way. And so by default that's set to off, although you can still turn it back on if you'd like. There's also a new help button. Previously I had all of the sort of help buttons next to each of the settings, but it gets a bit sort of cluttered and a bit, well, ironically somewhat complicated. So there's one big new help button and a new window to describe what all of those, at least main window settings do. This again will also be either a tabbed or at least a sort of context-aware help menu, so there will be a help window for all of the result settings we just looked at for a bit more detail on them. But this hopefully will help sort of describe what the different settings do, what the sort of recommended options for them are, and all that sort of stuff. And then we get to the bit that I'm probably most excited about, which is the blue heat maps and graphs folder. This is the sort of results view. It is still somewhat unstyled. It hasn't had the new lick of paint on it just yet. I'm sure I will at some point, although I probably won't before this update actually goes live. That'll be a future revision. If I keep tweaking things, it will just stay in, in development forever. So I'd rather get it out and actually make use of it. But you essentially have the main importing options here, right? You have the process raw data section, which is what you can use to, well, process your raw data. If a test failed for whatever reason, you can take a look and try and process it again. Or if you want to reprocess your data with a different methodology, maybe you originally ran the test with an older methodology and then you want to swap over to a newer, more accurate one, whatever else, or just be able to compare results to, say, a different publication who use, say you want to compare to Tim from Hardware Unboxed. Do you want to set that to the 3% of the RGB values? You can change that in the options menu, which options are just at the top, opens up the same window, same settings, and then you can import either an individual raw CSV file, or you can import an entire folder and then have it average all of that data as well. If you want to just view the heat maps of a processed file, whether that's one of the sort of full -OSRTT CSV files or one of the final averaged data files, the one that has normally the monitor name and the refresh rate and the connection type, then you can import that there. I'll do that one for now. In fact, I have an insane amount of tests. In fact, you can see all of the validation tests that I've done. There's a fair few of them, but if I import, let's go with this one, and let's go with the processed one down there. So that brings us up the new heat maps. This is something that I spent far too long working on, but it's close to being what I'm sort of happy with. There's a few little tweaks that I still need to do, but for all intents and purposes, you have your standard collection of heat maps with your standard sort of color keys, as it were. These are all color coded to the key that's on screen. For the time being, those keys are fixed in place, as in both the colors and the tolerance values, as it were. But in a hopefully very soon future update, you'll have the option to be able to customize both ideally the colors and the numbers, but at very least the numbers themselves. But yeah, that's the heat maps. It's obviously kind of what you would expect. All of the data is collected and saved in the files themselves for things like what tolerance values were used and what things like refresh rate was run at the time. It also does support recording what FPS was run, what FPS limit you were running on, and things like vsync, which I might include as a run informations table sort of in the middle here, this big blank space. But for the time being, that is how we have it. Now the thing is, while we have only imported a single file here, If we go back to the import data option and process an entire folder, which you'll have to excuse the sheer number of options I have and the fact that my mouse's scroll wheel doesn't work anymore. If I process that again, obviously it still opens up your Windows Explorer folder for that, but we now also have the option to view not only the averaged data, the sort of outlier rejected, well, average data, you can also look at each individual run on its own. And you can actually use the scroll wheel to scroll through these, or I think even the arrow keys. Yeah, you can, yeah, as long as it's selected. Bit of a weird quirk, but there you go. So you can search through them all, which is quite useful for seeing any of the sort of random erroneous results that might pop up, and any patterns, or you can look at the consistency, as it were, and obviously check for any outliers as well, which I think is a really easy and useful way to look at it. I should also mention that you have a view option up here to change which type of response time you want to report. Personally, I prefer and would recommend using perceived, that is the default, but if you want to use the initial response time, which is what the sort of VESA standard is based on, you can swap to that, or if you want to view the complete response time, which is often not inaccurate, but a little bit almost pedantic, if you like, then you certainly can as well. You also have the option to save these as the whole heat map as a transparent PNG, which I think is great for sort of publishing the results. It's really easy to stick that in a video or stick it in a written article, and all you do is click it and it goes and saves that as a transparent PNG. And the final section here is the graph raw data option. Now, this is both an advanced and very powerful tool to be able to validate a whole load of different things, including things like if variable refresh rate support is actually working or not, and to see if what's going on with the monitor. For example, looking at this data, this is from the AOC AG274QXM, I think if I got that name right, the mini LED monitor, and you can see that it is pulsing its backlight fully on and off every, I think, like half a millisecond, which is less than ideal. And makes processing that data very difficult, but that's the sort of thing that you can catch using this feature. You can obviously import a single file or an entire folder, and I've already gone and imported an entire folder, and it does pretty much exactly as you'd expect. It graphs your raw data. This is a fully interactive graph, so you can drag it around, you can zoom in, if my scroll wheel would work. And the span that it shows you here is a draggable span, which means that you can manually measure anything that you want really easily. These sort of undulations you see in the top are the monitor refreshing, and so if you want to measure essentially the refresh rate window, which again, really useful for catching any monitors that don't properly support variable refresh rates, this is a great way to do it. You can see this 165 Hz monitor is refreshing right around 6.1 milliseconds, which is exactly what you'd expect, which is good to see, and obviously variable refresh rate wasn't a factor here. You can just hit refresh to reset it back in place. You can select which run you want to see, which is a really useful thing for, again, looking at consistency, catching any little outliers or unusual results. And you can also select which transition you want to see as well. So maybe you want to look at, it going the other way. You want to look at the noisy sort of low end, or you want to look at the, brighter high end. There's lots of different options. There are some more things that I want to do with this, add a load more controls, things like I want to be able to have a vertical span to be able to select your overshoot amount, and a few more controls. But for how it is, I'm relatively happy with it. I should note that the perceived response time is what is displayed by default, but you can use the view menu to change which of those you fancy seeing, and you can also change what tolerance level you want to see, both for the response time and for overshoot as well. Finally, you can also save this as a transparent PNG, either the graph itself with the horizontal span, the response time displayed, or without that block, just as the raw data if you want to, say, annotate it yourself in your articles or videos or wherever else you want to use it. The only thing that's missing from this right now is the input lag processing or reprocessing the input lag data. That is something that I will be able to add very easily. I've already moved that processing function into the same sort of collective process data file, so I will be able to do that. It's just something that I haven't done just yet, and there's also a few things that I want to tweak about the input lag testing to make it even more useful as well. But if I hold on to this whole update until I've done all of that, it'll take another couple of weeks or month. So I thought it's better to get this update out, to get it in your hands, and then carry on updating and working on things after it's out and all that jazz. With this update, there is likely to be a few more sort of mid-run errors that might occur. I'll do my best to quash those as quickly as possible, but I'm also doing my own testing to make sure that everything is as sort of robust as possible. And like I said, all of the measurements themselves, all of the response times that it reports are all going to be the same. The processing functions haven't changed, and so none of that data should be any different, just how it gets displayed. And as long as you have the CSV version instead of the Excel file version, you should be able to use or import all of that data into the heat maps in the program to save that out as an image if you fancy anyway. So yeah, if you can't tell, I'm incredibly excited to get this out into people's hands. I'm hoping to have it live either as you see this video or in the next day or two. I want to make sure that I can do as much testing and validation as I can to make sure that it's as smooth and as sort of easy to use as possible. But that's kind of that, really. I would love to hear your thoughts, both from any users of the response time tool and as a viewer. What do you think? Is there anything that you think I should change, add, modify, whatever? What do you think of the design as well? Feel free to let me know your thoughts on that. And yeah, if there's any features you'd like to see, feel free to let me know about those as well. I can't guarantee anything, well, I suppose, as is the truth, I'm one idiot doing all of this pretty much in my spare time. This isn't a sort of professional device, as it were. I'm not sort of offering a finished product for people to purchase and for ultimate support on. It's more of a I made a thing and I think it's quite nice and quite cool. If you want one, you can fire me an email. But yeah, that's kind of that, really. I think I'll leave it there. I'm kind of rambling already. If you can't tell, I don't have a full script for this one. So yeah, hope you enjoyed the video. Feel free to, like I said, let me know what you think in the comments down below. If you want to support my my madness, feel free to both hit the subscribe button if you haven't already and the notification bell. Check out the other OSRTT videos on the end cards, and you can also support directly, either just through the sort of direct sort of donations, as it were. Obviously, you can pick up one of these devices from me if you'd like. Stock availability, as it were, is kind of a little on the low end parts availability, and again, one idiot building them all. Takes some time, but there's also indirect ways through YouTube, through Patreon, merch hoodies or t-shirts like this one, all that sort of stuff, and all of the affiliate links are greatly helpful as well. So yeah, like I said, I'll leave it there. Thank you for watching, and yeah, we'll see you on the next video.